Hello everyone, I'm forecaster Jack Sillin here to discuss the severe weather setup for the afternoon evening of Monday, May 21st, 2018. We're going to start out with a look, as always, at our GOES East water vapor satellite imagery here. We can see that there's an upper level disturbance here near Sioux Falls, South Dakota. This is a portion of a large upper level trough that has persistently been hanging out along the west coast here. And that kind of filament of that trough has broken off and is ejecting off to the north and east. And the energy associated with that is going to help to fuel some severe thunderstorm activity today across parts of the Ohio Valley, especially Indiana into Ohio. So we have this moisture here, we have a little bit of a lift out ahead of that upper level disturbance, and those ingredients are going to set the stage favorably for severe thunderstorm activity in this area later on today. Looking at our infrared satellite imagery, we get this because visible satellite imagery is not available until the sun kind of fully comes up. So to get a better picture of the setup, we're going to use infrared imagery. It's fairly similar. We can see plenty of cloud cover, some shower and thunderstorm activity here in Illinois. Cloud cover off to the east. There's a little bit of a boundary here, and we'll take a closer look at that in a minute. But basically, these clouds are going to help to limit instability a little bit. So not quite enough to fully inhibit or prohibit severe thunderstorm activity, but just enough to make it a little bit less intense than we might otherwise expect. So keep an eye on those clouds as a kind of limiting factor for today's severe weather potential. Here is a look at our surface winds here as of 6 a.m. Eastern. And as you can see, there is a boundary here stretching from southern Ohio up through south central Indiana and into parts of central Illinois. North of that boundary, winds out of the east-northeast. South of that boundary, calm winds. This is a warm frontal boundary that we'll be watching today. It extends back to the west into parts of northern Missouri here. This is where surface low is located, so you can see those winds kind of spiraling around counterclockwise, so that suggests an area of low pressure right in here. And then down to the south of that, you can see a cold front with northwesterly winds behind the cold front and southeasterly winds out ahead of it. So we'll be watching the cold front and the warm front here as the surface low tracks off to the east-northeast. Here's a look at the ECMWF's thunderstorm composite map. You can see clearly our warm frontal boundary, the kind of northern edge of the instability here, and you can see our cold frontal boundary, kind of the western edge of the instability here. Also notice even in the warm sector here, a little bit of decreases in instability. That's again due to the cloud cover, so kind of a limiting factor up in this area. Will be those morning clouds, which will limit the amount of daytime heating that can occur, and when you limit the amount of heat that the surface gets, you limit the vertical temperature gradient, so keep an eye on that. If we click the map to zoom in a little bit closer into the area that we're watching today, so that's specifically kind of central Indiana, east into parts of west central Ohio, we can take a look at some of our wind profiles here. So at the surface, we have weak southerly winds here to the south of that warm front. Those become southwesterly in the mid-levels and west-southwesterly in the upper levels. So we have that rotational energy that generally veering with height wind profile. But notice the winds aren't particularly strong, so we'll be keeping an eye on that. But enough to support rotating updrafts with any storms that develop. Another thing to keep an eye on with that boundary, that warm front, is that to the north of that, there's going to be plenty, or even more rotational energy once you get those like due easterly winds. So the contrast between the due easterly winds that become westerly, so you get kind of a 180 turn out of that compared to the southerly winds that become westerly. So you only kind of get a 3/4 turn, or rather you get a 360. You make a full revolution around the circle there if you start with easterly winds and you end up with westerly winds, as opposed to kind of a half turn. So we'll be watching the area of enhanced rotational energy along and to the north of that warm frontal boundary. Any storms that develop and can actually latch onto that boundary will get kind of a boost of rotational energy known as vorticity. So boundaries have vorticity associated with them, and that's basically can just be thought of as turning rotational energy within the atmosphere, and when storms get a kind of shot of that to the heart, if they can latch onto the boundary, they have a much higher chance of producing a tornado. So we can actually see the NAM model is kind of trying to do this with a storm in Indiana. So you can see that we have this warm frontal boundary. It'll lift to the north a little bit of where it is now. And then this storm that develops here, actually, according to the model, is going to try to latch onto that. And you can see how it kind of moves. It turns off to the right as it kind of latches onto that boundary. And you can actually see the little hook echo formation here. So again, these simulated radar images are not supposed to predict county by county where storms will hit. There is no indication that these particular counties in Indiana here are at a particularly high risk for a severe thunderstorm or a tornado. It is merely to suggest that thunderstorms that form in this area along that warm front could latch onto the boundary, and that latching onto the boundary could make them more ripe for tornadoes. For tornado formation. So watch that. Again, don't take these maps too literally, either in my videos or when you're seeing them for yourself on our weathermodels.com website here. And just take it as a kind of general guideline that storms in this area could latch onto that warm front, and if they do, we could see these kind of hook echo formations that indicate strong rotation and potential tornadoes. Storms will kind of congeal into a more linear structure as we move later on into the night tonight before they weaken as they move southeast. So that's a look at what to expect from these storms. The main threats will be damaging wind and large hail. Tornadoes are possible, especially along that boundary that we talked about, but damaging winds and large hail are going to be the primary threats today. Of course, any thunderstorms, severe or not, do produce dangerous lightning and torrential downpours. So watch out for those, even if the thunderstorms headed your way might not be severe warned. That's it for me for now. I'll have more updates this evening. Thanks for watching.